Hello everyone, and dear sir, welcome to my presentation. Here is our group members, and I'm Sagar Hussain going to present this presentation. My presentation topic is Introduction to Virtual Memory. What is virtual memory? Virtual memory is a space where large programs can store themselves in form of pages while their execution and only the required pages or portions of processes are loaded into the main memory. This technique is useful as large virtual memory is provided for user programs when a very small physical memory is there. In real scenarios, most processes never need all their pages at once. For following reasons, error handling code is not needed unless that specific error occurs, some of which are quite rare. Arrays are often oversized for worst-case scenarios, and only a small fraction of the arrays are actually used in practice. Certain features of certain programs are already used. Benefits of having virtual memory. Large programs can be written as virtual space available is huge compared to physical memory. Less I/O required leads to faster and easy swapping of processes. More physical memory available and programs are stored on virtual memory, so they occupy very less space on actual physical memory. What is demand paging? The basic idea behind demand paging is that when a process is swapped in, its pages are not swapped in all at once. Rather, they are swapped in only when the process needs them. This is termed as lazy swapper, although a pager is a more accurate term. The pages that are not moved into the memory are marked as invalid in the page table. For an invalid entry, the rest of the table is empty. In case of pages that are loaded in the memory, they are marked as valid along with the information about where to find the swapped out page. Here is the example of how demand paging works. There are cases when no pages are loaded into the memory initially. Pages are only loaded when demanded by the processes by generating page fault. This is called pure demand paging. The only major issue with demand paging is after a new page is loaded, the process starts execution from the beginning. It is not a big issue for small programs, but for larger programs it affects performance drastically. What is page replacement? As studied in demand paging, only certain pages of a process are loaded initially into the memory. This allows us to get more number of processes into the memory at the same time. But what happens when a process requests for more pages and no free memory is available for bring them in? Following step can be taken to deal with the problems. Put the processes in the wait queue until any other processes finish its execution, thereby freeing frames. Or remove some other processes completely from the memory to free frames. Or find some pages that are not being used right now. Move them to the disk to get free frames. This technique is called page replacement and the most commonly used. We have some great algorithms to carry on page replacement efficiently. And now about the thrashing. What is thrashing? A process that is spending more time paging than executing is said to be thrashing. In other words, it means that the process doesn't have enough frames to hold all the pages for its execution, so it is swapping pages in and out very frequently to keep executing. Sometimes the pages which will be required in the near future have to be swapped out. And that's all. Thanks for watching.